Demodulation is a process of extracting the original information signal from the modulated carrier signal. Before moving ahead, pause the video for few seconds and recall how AM signal is demodulated. Thus, we can see that in AM demodulation techniques, an envelope detector is used which gives the rectified output consisting of only positive pulses which are further applied to a low pass filter to get a smooth demodulated signal. Let us now see how ASK signal is demodulated. ASK signal is demodulated using two different methods. One of the method is using asynchronous detection method, which is also known as non-coherent ASK demodulation technique, whereas another method is using synchronous detection, which is also known as coherent ASK demodulation technique. In asynchronous detection, no reference carrier or clock pulse is required at the receiver to extract the original information from the received signal. While in the synchronous method, a reference carrier or the clock signal, which is same as the one used for modulation at the transmitter, is used in the receiver. This reference signal or synchronous carrier can either be generated at the receiver or it can also be extracted from the incoming modulated signal using carrier recovery circuits. Let us now see in detail how ASK signal is demodulated using asynchronous or non-coherent demodulation technique. Figure shows the ASK signal which consists of two different amplitudes. In order to demodulate this signal, it is first applied to a simple half-wave rectifier circuit. The rectified output is as shown. It consists of only positive half-wave outputs consisting of half high-frequency components. In order to smooth the signal, this rectified output is further passed to a low-pass filter to suppress the high-frequency components, giving rise to an envelope-detected signal as shown in the figure. It can be seen that for higher amplitude rectified signals, the filtered output is of high amplitude, constant signal, whereas for lower amplitude carrier signal, filtered output is of lower amplitude constant signal, thus resulting in an envelope detected signal. This combination of a rectifier and a low pass filter circuit is also called as an envelope detector. As the filtered output consists of only two voltage levels, a simple voltage comparator is used to identify a bit 1 or 0. For this, the reference voltage for a comparator is set between the two voltage levels of a filtered signal. During each bit duration, the filtered output is sampled and compared with the reference voltage in a comparator. If the sampled value is greater than the reference voltage, then it is detected as bit 1, and if the sampled value is smaller, it is detected as bit 0. Thus, output of comparator results into a demodulated signal as shown in the figure. In this complete demodulation process, nowhere reference clock or carrier signal is used. Thus, it is a non-coherent type of demodulation technique. Another type of demodulation technique is synchronous or coherent ASK demodulation method. The first block in this type of demodulation is a mixer. To the one input of mixer, ASK modulated wave is applied, whereas to its other input, synchronous carrier is applied. This carrier can either be generated at the receiver or can be extracted from the incoming modulated signal using different carrier recovery circuits. The output of a mixer is a product of an ASK signal and a carrier which consists of DC components along with high frequency signals. These high frequency components are of not much use and so they are filtered out using a low pass filter. Thus, at the output of a low pass filter, during each bit slot, a constant DC component appears. The amplitude of this DC constant depends on the transmitted bit 1 or 0. This signal is further applied to a comparator which has a reference signal set to a value in between the two DC component values. Thus, during each bit slot, incoming signal is sampled and compared with the reference signal, and based on it, the signal is detected as 1 or 0 at the comparator output. As this process uses synchronous carrier, this type of demodulation technique is known as coherent demodulation technique. Let us now see the spectrum of ASK signal. The first figure shows the spectrum of a digital signal band limited to frequency omega d max, which is an angular frequency, which is obtained by passing the square wave signal into a pulse shaping filter in order to remove higher harmonics and limit the bandwidth of the modulating signal. The second figure shows the spectrum of the carrier signal with an angular frequency omega c. The third figure shows the spectrum of ASK modulated signal extending between omega c minus omega d max to omega c plus omega d max, which is centered around the carrier. Thus, ASK signal has a maximum bandwidth of twice omega d max. Let us see now the advantages of ASK signal. Major advantages of ASK is that this signal is easy to generate, and because of this, the circuit for modulation and demodulation of ASK signal is very simple and less complex, and thus we can say it is inexpensive. The bandwidth requirement is also less compared to the FSK signal. Let us see the disadvantages. The disadvantages of ASK signal is that it has low power efficiency. The signal is very sensitive to noise and gets affected soon as the noise affects the amplitude. This you can similar to amplitude modulation technique. It is generally used at a very low bit rates, say around 100 bits per second. It also has low bandwidth efficiency. Now, as far as applications are concerned, ASK is generally used to transmit digital data over an optical fiber. It is also used in the RF modules such as RF remotes, RF car keys, etc. The on-off keying signal of ASK is used at radio frequencies to transmit Morse codes. Thus, we have seen how ASK signal is demodulated, its spectrum, advantages, disadvantages, and its applications.